Hey Huskies, we are going to do a little bit of a review. I know you just took a test, but this is going to help prepare you for the unit coming up. To start off, remember when we did this way back at the beginning of the year? Write out in words what this compound inequality means. Do you see how x right here is in between -6 and 14? Well, what that compound inequality means is all the numbers between -6 and 14. Numbers between. Remember when we talked about how my dog could weigh a certain weight and he would still be healthy? All the numbers between -6 and 14, including -6 and 14 because it could be equal to those. Okay, then number 2 says graph on the number line all the numbers between 27 and 30, but this time they do not include 27 or 30 because there's no equal to bar underneath there. So we're just going to do open circles and we're going to color it in to represent all the numbers in between there. We could have 27.01, we could have 29.99. All of those numbers work. Speaking of what works, let's give two solutions to this inequality. If you read that, it says x is greater than or equal to -37. So what's a number bigger than -37? How about -36? How about 0? How about 412? How about -37? That's equal to, that's a solution. So this is just all the numbers that you can think of. Well, we only need 2, but anything bigger than -37 works. Number 4, find y when x equals 150 if y equals 2x plus 9. This is your basic plug it in, plug it in. X is 150, that means instead of x, I'm going to write 150 plus 9. Well, 2 times 150 is 300. 300 plus 9 is 309. How about number 5? This is actually the same idea, but I wanted to give you a little bit different notation so you could see that I might ask you to do the same thing in 2 different ways. Evaluate f of x equals 2x plus 9 if x equals -381. Oh, okay, that means really what I'm finding, excuse me, I'm choking on my oatmeal. Okay, we're finding f of -381, and that's going to equal 2 times -381, because instead of x we have -381. Oh, squish in a plus 9 right there. Okay, so then f of -381 equals, when you calculate all that, it becomes -753. So some of you might be wondering, well, what about this? What do I do with that? That's just the same as saying y. It's just giving us a little bit more information that this is what y equals when x is -381. We found y when x equals -381. So remember, anytime you see f of x, you can just replace that with y. They mean the same thing. Okay, number 6, is the slope of this line positive or negative? It is negative. It is going down from left to right. You've got to be able to know by looking at it. Is it going up or down? Well, this is going down because if there was a little roller coaster on here, then it would be going down. We're talking left to right, just like you read a book. That guy is going down. Yay! And having fun. So that is negative. The slope is negative. It's going down. Now write the equation of this line. Well, to write an equation of a line, we are going to use y equals mx plus b, with m as the slope and b as the y-intercept. It looks like my y-intercept is 2, so that's easy enough. And we're going to have y equals something x plus 2. What's my slope? Well, you can draw this slope triangle on here if it helps, so that you could see that we actually went up 2 and over 4. Why did I choose to go to that particular point? I don't know. It just looked like a nice lattice point. You could have done this for your slope triangle. And at any rate, oh my goodness, that's not going over 4. That's going over 8, isn't it? My bad. And so the slope is 1. The rise is, well, let me do it this way. The rise is 2 and the run is 8. And then if we simplify that, that becomes 1/4. So it's actually 1/4 x plus 2. Okay? Next. Oh, this is small. Here we go. Let's make it bigger. Write the equation of this line. Well, it's a horizontal line, which tells me it's going to be y equals just a plain number. And what is that number? Well, it's going through negative 3. This is what y equals no matter what. You can make a table if you want. No matter what you choose for x, y is always going to equal negative 3. That's what it looks like. So here's your equation, y equals negative 3. And so number 9 is one of those vertical lines, but it's the same idea. So it's like an axe, right? Vertical, vertical, tomahawk chop. So x equals 5 is the equation of that line. Those should be pretty simple. Okay, now I'm not going to do all of these for you, but I am going to review a little bit. So number 10, we're supposed to write an explicit and a recursive formula for this. So first of all, we have to know what kind of sequence is it. So it looks like from negative 4 to negative 16, how did I get there? Well, I have two choices. I could either be multiplying by 4, or I might be subtracting 12. I don't know. How did I? Okay, well, it's either of those. So let's just check the second one. Negative 16 minus 12 is not negative 64, so we know it's not subtracting. And negative 16 times 4 is negative 64, so that means that my pattern is multiplying by 4. I'm going to start off with writing a recursive formula, because that's what we started learning this year. What is my zero term? It is negative 4. In the beginning, there was negative 4. Now, this is the vomit part. F of x equals f of x minus 1. That's just the same no matter what your recursive formula looks like. You're always going to have that part. And then we just throw the pattern on the end, which was to be multiplied by 4. And that's your recursive formula. Now, the explicit formula, think back to when we were doing exponential growth. We're going to start off with f of x, and we're going to put on our... I'm going to do this with the first term just for fun, which was negative 16. And what was my pattern? I am multiplying by 4. And since negative 16 was my first term, I'm going to have x minus 1 as my exponent. I could have written a couple of other explicit formulas. I could have used my zero term. My zero term is negative 4. My pattern was multiplying by 4. And then my exponent will just be x, because it would actually be x minus 0, which is just x. And then you could do it also with the negative 64 for your second term. Okay, how's that for a review? If you look at number 11, we're going to do the same thing. How did we get from 5 to 2? Well, maybe we subtracted 3, or maybe we multiplied by 2/5 or something crazy. No, it's just simple, nice and simple, subtracting 3 every time. So then our recursive formula is going to start with our first term, because we don't have a zero term, but you could find it if you want. F of 1 equals 5, and f of x equals f of x minus 1. I hope you were all vomiting right there. Blah. And then we're subtracting 3. That's our pattern. So that is my recursive formula. Now, an explicit formula, this must be an arithmetic sequence, because I'm adding negative 3 every time. So that's going to be f of x equals, where did I start? At 5. And what's my pattern? Subtract 3, and 5 is my first term, so I'm going to have x minus 1 there. If you wanted to simplify this, distribute your negative 3, hey, what's 5 plus 3? It's 8. So 8 minus 3x is also an acceptable equation for explicit. And if you think about that, if you rolled this table back to the zero term, it would have been 8. And so you could put that in slope-intercept form by saying, hey, my y-intercept is 8, and my slope is negative 3, because I'm subtracting 3 every time. So that works as well. All right, I'm going to let you do number 12. And then on number 13, you're just supposed to figure out what's missing. So I'm going to let you do number 13, but I'm going to talk about number 14. When you have two gaps like this, it's kind of hard to start there. I would start with trying to find the third term and make sure I actually know what the sequence is. And guess what? There's a pretty good hint right there. So that's all I'm going to talk about with number 14. But now on to number 15. This one's a little bit harder because we don't have two consecutive numbers anywhere on here. So I'm going to have to make kind of an educated guess. Let's see, I've got a 5, and the last number, the last digit of each of my numbers ends in 5. So I'm betting there's a 5 involved, probably as my pattern. How do I get from 15,625 to 390,625? Well, the 625 reminds me of something. It reminds me of 5 to the 4th power. So I'm going to guess that I'm multiplying by 5 every time. So what would happen if I multiplied this by 5 and then multiplied that by 5 again? Would I get to 390,625? Test it out on your calculator and you'll see that if you multiply 15,625 by 5, you get 78,125. And lo and behold, if you multiply that by 5 again, you do get 390,625. So that means that my pattern must be I am multiplying by 5. And so you can go ahead and finish filling in the rest of that table. I hope that helps you review a little bit and get ready for our new unit. Functions are fun.